I have a lot to talk to you about, so it's probably a good thing we have a little bit more time. But yeah, I want to tell you a bit of a story. So we're going to go through a bit of a story. I'm going to go through some video demos of the kind of full process, but please ask your questions. Really keen to answer them towards the end of the session. So welcome to this session. We're going to talk about making sense of your unstructured data with AI. I'm one of our cloud advocates, as with our other speakers, and we are going to talk through a business scenario using unstructured data and applying AI and search services to actually solve this business problem. So let me first talk a little bit about the business problem itself. Tailwind Traders are a fictitious retail company. They deal with DIY, do-it-yourself goods. They have shops and stores all over the world. Actually, I was about to say a country, actually all over the world. And one of the things that they're finding is their invoices are in this format here. So what you see on the screen, we've got a few examples, and then I've kind of like zoomed in a little bit on an example. All of this data is in a PDF, and PDFs can come across as being actually really hard to extract data from. What Tailwind Traders want to get from this is they actually want to understand where this invoice came from, what date, what was the actual total amount, who bought a gnome from Tailwind Traders in Australia, for example. That's the kind of detail that they really want to go into, but they're currently in this PDF scenario. Also, one thing to note, this is one of the stores, has invoices dating back to 2008 in this kind of folder structure. And if you take a look at how many files there are 140,000 files. And this is just one of the stores. So one of the key things we need to solve here is all around automation in order to gain efficiency. The Tailwind Traders technical lead heard about search as a service on Azure. So what is that? That is a service called Azure Cognitive Search, a set of developer APIs and tools that allow you to build a really rich search experience over your heterogeneous data. So let me break down those terms a little bit. Search experience, literally thinking like when you use a search engine, but say on your organizational data itself, not on kind of like public data. Heterogeneous data is all of those different data types, a bit like what Amanda spoke about. We're talking images, PDFs, files, structured data, unstructured data, all sorts of different things. And so the idea is basically using cognitive search to break down some of that content and understand what's going on inside it. So let me explain how Azure Cognitive Search actually works. First of all, we're going to take a data source. Our data source is going to be our Tailwind Traders PDFs. We're going to do something called document cracking. So cracking is basically opening up that document and understanding what's going on inside. So rather than just metadata, file name, file size, etc., actually understanding what is going on in the content. Once we have this document cracked open and we know that there's content inside, we can actually apply something called skill sets. Cognitive skills can use the Azure Cognitive Services, so all the things we've seen before this, image, text, speech, etc. But you can also build your own custom skill sets to do any kind of processing that you wish. Once you've applied all these, you get this enriched document, this document where you know what's going on inside of it, but you also know about all of its metadata. And having all of that metadata actually allows you to then have this search index idea. So I want to be able to search for all the PDFs invoices from Australia, or all the ones that include a gnome, for example. Not sure why I'm stuck on the gnomes here. Okay, before we dive in, because there's a lot of demos that I want to show you, I want to talk a little bit about the architecture. AI never sits alone. It's never just one single service. It's built into an architecture. So we're going to have our PDF invoices stored in an Azure Blob Storage account. We're going to actually connect them as a data source to Azure Cognitive Search. Cognitive Search is going to have a skill set that points towards an Azure function. This function is going to call the Azure Cognitive Services, and specifically the Forms Recognizer API. Really excited to show you that, some really cool stuff there. It will pass back all of its information back to the Azure function. The Azure function will do some pre-processing, so it will tidy up what we get back from that API, and pass it back to cognitive search to actually bring together the data, the skill set, and the index. Once we've processed all of those PDFs, the full 140,000 PDFs, we're actually going to store it in something called a knowledge store, which is an Azure table storage. And then finally, the key point on the end is actually creating that search interface. So either building an Azure App Service or building it into the applications that you already have so that your users or your customers can actually start searching across data, or something like a business intelligence tool. So first things first, we are going to cover a lot here. There's going to be a lot going on. We're going to go into some detail. So visit aka.ms/AIML30 for you to go and get hands-on after this session and really dig into the concepts that I'm going to cover. So let me just drop over to our demos here. Okay, so here we have a PDF, Tailwind Traders PDF. And one of the things that is really, really great about this is I'm actually able to see all the different values and stuff like that. Inside Azure, I've created an Azure Cognitive Service instance for forms recognizer specifically. So this is going to analyze and extract key value pairs from our PDF, and we're going to call it by using the endpoint and the keys for this service. So now we have our instance in Azure. We're actually going to go over to something like Visual Studio Code. So in my case, that's what I'm going to use, but anything to call an API. And I'm going to use some curl statements in Visual Studio Code to actually retrieve training results and analyze new forms. So let's zoom in a little bit here. Do go into full screen mode for this bit if you wish. The train model basically calls off to the API. So the forms recognize the API in Azure, and it calls the custom models part of that API. We're also going to pass it JSON data. I'm going to pass it also my key, so I know I'm interacting securely with the API. And then the other thing I need to pass it is the source of the data. So what I'm going to do is I'm going to head over to Azure Storage Explorer, and I'm going to select in our training data set the whole container and get a shared access token. So the shared access token means that the service can actually access this data. It has permissions to. And what you'll notice is we have 5 different PDFs in there. So I'm going to take this curl statement and post it in. What we're going to see is we get a 201 created and kind of lots of other information. But the key piece is this URL, because now this ID at the end of the URL is our specific forms recognizer model. So it's trained on Tailwind Traders invoices. Now we need to retrieve the training results. I'm not just going to trust what the terminal tells me in this case. So I'm going to pop my model ID into the API query. And then all we need to provide is the key for this piece. So I'm going to pop that into the terminal, and I get the this JSON response back. Now, JSON's quite hard to read, I always find, in the terminal. So what I'm going to do is I'm going to copy this, put it into a JSON file, and use Shift-Alt-F. Shift-Alt-F is my favorite Visual Studio command to format JSON. And what we'll see is you've got lots and lots of invoices that I've trained my data on, and they say succeeded. But we don't just want to stop there. We want to know whether this actually works for data it's not seen before. So what we're going to do is we're going to analyze a new form. To do this, we need to fill in a few little gaps in our statement here. So first things first, let's take that model ID, so the Tailwind Traders invoice model specifically on our data. And I'm going to get some source data again. This time, I'm going to use the test container because I don't want to pass it something it's already seen. I've got a lot of good examples in here. So let me copy another SAS token for access. And I'm going to take this statement and pop it in the terminal. Lots of stuff going on there, but basically it's run. And then what we really want to do is get back what did it extract from our form. And so to do that, we're going to use this get results. We're going to pop in that model ID. And again, just like previously, if we look at what it returned the model ID, then analyze results / and another ID. So we'll put that in our result ID. We'll take that statement. Well, lots and lots of JSON here for us. So my favorite command is in order, Shift-Alt-F. It was going to give us some great formatting. look at the size of that document over there on the right. So this is all the key value pairs that the forms recognize actually extracted from my invoice. So it took out name, name was Brian, it took out address was 1145, but it also takes out every bounding box, so the actual space on the screen where it's being used. So we've trained our forms recognizer, but how do we integrate it into our cognitive search experience? Well, I've got some sample code here inside Visual Studio Code. This sample code is from the Azure Cognitive Search Power Skills GitHub repository. They've built some amazing sample code that's specifically for forms recognizer to build it into Azure Cognitive Search. So I took this code as kind of an idea of best practice. And all I need to do is basically change some of the settings. So I'm going to provide my forms recognizer, my cognitive services, endpoints and keys, as well as that model ID. So the model ID that's trained on Tailwind traders. And then in field mappings, this is the only data that I want it to provide back to Azure Cognitive Search. I don't need the bounding boxes. I just want these key value pairs so that I can search across that data. So let's run this code. And actually, one of the nice pieces here around Azure Functions is I can actually run this locally. If you notice, this is a localhost API / analyze form. I'm going to take that and pop it into Postman. Postman's another great way to call REST APIs. And all I need to do is then provide it a form. So a bit like what I did when I trained and test the API. So I'm going to get a different form this time and grab the URI. Let's pop that into Postman. So what we'll see is the URL is there, but I'm going to take the SAS token off the end and actually put it in the segment below. So it's definitely got what it needs here, and click send. And now what we see is we've analyzed this data, but all we get back is not all that, huge file. We just get what we need back. So the function has done some great pre-processing. Just to note, gives you some good stuff in the terminal to when you're debugging. This was really useful to actually tell you that it's extracted everything. Now, I don't want to stop there. I don't just want it to be on my machine. I want you to all be able to use it as well. So I want to put it into an Azure function. We've got the same code here, but I click on the Azure icon on the left, and we can see I've created an Azure Functions instance. So you can do that by just clicking Deploy to Function app. It's such a good, quick experience. I'm not necessarily an app developer, so this was a treat. It asked me for things like name and location. But also, one of the other pieces, Seth's going to join us actually shortly to deliver a different session, but he taught me about this application settings. So if you open these settings, what you'll notice is all my forms recognizer pieces, that I put in that local settings.json file. I can click upload local settings, and it will just take those settings across and push them up to the cloud. This is great. This means no keys in code. This means everything's stored securely in Azure. So this is what it looks like in the Azure portal. I've got these functions here. We can see that I've got a URL to call my function, and it's /analyze form, just like it was on the local host. One of my really nice pieces here was actually testing this. I felt good because it was inside the actual portal, so I knew it was definitely calling this one. And then you can do a post request. We can see it's exactly the same format as it was on my local host, but when I run it inside the Azure portal, I get the same output. So it's analyzing the form, it's provided me that feedback and just the data I need. So that's a really simple way to quickly check that it's doing what I expected. Okay, last step. I hope you're still with me. We have not even gone into Azure Search yet. Now we are in the Azure Cognitive Search service. And there's multiple things going on here, but basically this is going to connect everything together. So we have things like data sources, which is our blob storage. We have skill sets, which is our function. We're going to create an index, and the indexer is the workhorse of the hour, basically. So to do that, all you do is call APIs. So we're back in Postman again. We're going to add our skill definition. So our skill is our Azure function, and it calls off to our forms recognizer. So it extracts data from our PDFs. I'm calling off to the skill sets API and calling it forms recognize a skill. What I'm going to do is also provide it, just tell it it's a web API skill, and this is the URI I want it to call. So this is my functions URI with a token for secure access. I also tell it what the input schema looks like, which is my form URL and SAS token, as well as what it should expect to bring back to Azure Cognitive Search. So that is all of our key value pairs that are very neatly formatted for us by our function. So let me send that off. We can see it's 201 created. There's some good stuff in there, but I actually like going back to the portal. If we go into skill sets and click refresh, we can see I've got this forms recognizer skill with one skill. So that is call off to my Azure function, and my Azure function does the rest of the job. Okay, so we've got our skill set in place. Next up is our index. Our index is our schema. Think of it like that. What should Cognitive Search store in our knowledge store? What should it be extracting from the data? And what should we be able to search on? So we can see we've got our metadata at the top, but then we have our key value pairs all described at the bottom. Also note, you've got these other assets, so filterable, retrievable, searchable. These are important for the front end. When you're actually starting to search over this data, you can say what should be in the filters that you want to have people filter from, or what you want to actually be brought back, so what's searchable. So I send off that index. I can see my invoice is here. It's got no documents in there at the moment, but we're going to combine our data source, our skill set, and our index here, and it's the indexer. The indexer, as I said, is the workhorse. It's the piece that pulls everything together. So let's create our indexer. Same API, slash indexers. We're going to call it our forms indexer, so watch out for that in the portal. We're then going to tell it what is our data source, what is our index name, and what is our skill set. So bringing all of that together. We're going to tell it what are the input mappings, but more importantly, what are those output mappings? So those key value pairs from all of those 140,000 different forms. So this is at scale, right? This is automation at scale. So we've got a 201 created. We click on our indexer and we see our forms indexer. It tells us it's in progress, right? This could take a little bit of time. So if we refresh, we see it's now done 10 documents. So it is processing, it's doing a good job. Finally, we refresh again and we can see it's completed all 20 documents and it was a success. If I go into my index and just quickly refresh there, we see we now have the 20 document count. So that was my sample set of documents. And I can simply just search over these really quickly. So you can see here, we've got like the kind of messy, just pure content that was extracted just there. It's not like super useful to break down, but look at this nice, tidy key value pairs that I can search over so easily. For example, I only want data from Australia. I was talking about the people in Australia buying gnomes. So this is exactly how you can start to search. I'm doing this in the portal, but think about how this could be used if it was on, say, something like an Azure web app. So to wrap it all up, we covered so much there. That was not obviously real time. That takes a bit longer than the 12 minutes, I think, of demos that I have there. But I wanted to highlight on our architecture where each of these elements sits. So our data source is our blob storage. Our skill set is our function. Our index is actually the data that ends up being in our knowledge base at the end. And the indexer is cognitive search kind of center that pulls everything together. One thing we didn't cover in this was the front end. So actually being able to search over it. However, there's lots of great content out there that will show you that, including our amazing Microsoft Learn module. So if you go to aka.ms/AIML30, you can go and get hands-on. It's a slightly different topic, but you get exactly the same idea. And when you get in there and get hands-on, it all kind of pieces together, which is great. Little certification alert, go to aka.ms/AI900 to check out the AI Fundamentals certification. And otherwise, Jason, how was that? I probably went over, apologies.
No, that was amazing. You didn't go over it all. Well, no, we're good. Yeah, actually, I had to like bend over and pick up my mind because you just blew it with everything that just happened. Like it just blew me away. There's people on the stream for sure right now who are feeling the same way, because you just demonstrated that no longer do I need to manually read through a stack of documents and get those made sense of and put them in the right place. And like, there's a solution for it now. And it sounds like you definitely need to know JSON. You know, there's a lot of tools in there. I'm joking about the JSON, but there's a lot of it in there. You know, that Alt, what was it? Shift Alt F, I think is the secret weapon in VS Code.
I don't even know who told me that, but I think Microsoft Developer like recently tweeted about that, and they were like, "What's your favorite like shortcuts?" And I was like, "Oh my god, Shift Alt F, like definitely."
Right. Exactly.
Especially when dealing with all this kind of stuff.
If you have any takeaways from today, it's maybe try Shift Alt F if you're always doing JSON and VS Code. So there's a couple questions.
Modules, Shift Alt F.
Yeah, exactly. So we had a couple of questions that came in over with our audience over at Learn TV. First one is really just, I think, a general question for today's events and in general is recordings. Will there be some place that we can go and watch everything that took place today another time?
Absolutely. Yeah, I believe the Japanese and French events are already available on YouTube because they were live broadcast. But we will be putting together all of this content and we will make it available on one of our Microsoft channels. If you have registered for the event, so if you went to aka.ms/allaroundazure-AI, you'll also get a follow-up email and it'll have links to all this content in. So even if you didn't register, I think you can still register now. Go do it just to get the comms afterwards with all the great URLs.
Yeah, exactly. We definitely want to make all this stuff available for those who weren't able to join us today. Another question we have from someone, Mike, over in Learn TV is, how does ACS handle changes in data structure changes?
So I'm going to interpret ACS as Azure Cognitive Services. I was going somewhere else. I was like ACI. I was like Azure Container Instances. I was like, I don't think I went
that's
there.
Where my mind went too.
I covered a lot, but that wasn't in there. How does it change? How does it handle, data changes?
How does ACS handle changes in data structure changes?
Yes. So for forms recognizer, this comes up a lot. So you only need to train your model on 5 forms is the minimum in some senses to actually get it to understand the layout. So if you have multiple different types of forms, I believe the best practice is to make multiple different models, right? Your model is then trained. It has an ID that you can access. So say you were doing the processing of this and you can actually then have say, okay, I want to run all these types of forms in Azure Cognitive Search from this data source, and that it will use skill set X. And then I'm imagining, okay, then I have like this legacy form or like a different type of form, and it will then do a different model. If the data is different, so say like instead of name, address, and someone bought a gnome type thing, if it's how it was actually something completely different, like a HR form for Tailwind traders, they need to be trained differently. If the data in the actual invoice, for example, it's not a gnome, it's a hammer, that's fine. It will understand key value pairs and format, but if there's changes in forms completely, like the structure, I train another model.
Okay, great. Hopefully that answers our question for our guests there. One other thing that I guess wanted to point out, or maybe just jam on for a minute while we're setting up for our next talk here, is you showed the ability to do things locally and then push up into Azure. Could you maybe just expand a little bit more on what's happening there? Yeah.
So what I did was when obviously, well, I'm gonna like air all my dirty laundry here. When I code, it does not work first time. There we go. I've said it live on air now.
It never does.
It absolutely does not work first time. And so one of the really nice things with Azure Functions, I've only recently got into it. As I said, I'm not like a hardcore app developer. I've obviously done a bit of that in the past, but realistically, I focus more on AI. The functions inbuilt packages and tooling, inside Visual Studio Code is really, really nice. And so actually what you can do is my function is just running a segment of code, right? It's just fire this function, run a piece of code. And so my code called off to things like forms recognizer, and obviously I have internet connection on my local machine, etc. But being able to test it locally was so good, you know, rather than being like, well, Damien on our team would be really upset as well if I right-click deployed without like testing. I know. Like, oh. If I did that, like it would take longer as well. And all I want to do is I just want to test. So especially when I was building, it was really important to like build that function up over time, edit small bits of it. So I changed the field mappings and I changed the keys. And as I said, doesn't work first time. So that runs locally. And then I pushed it up to Azure Functions once I knew that it was doing what I wanted it to do.
Excellent. And that's really, it really is a deployment of the Azure function into an app service type of thing, I think, within Azure. So yeah, very cool stuff. I love that I can work locally. I mean, I typically have internet connection all the time, but there's more and more ways lately where I can actually disconnect, still work on some stuff, and then later when I'm ready to reconnect. So thank you for pointing that out and highlighting that.